So I'm going to go over two examples from this 3.2 homework. This first one gives you that f of x equals 10x squared, and the first question is to evaluate f of x plus h. So I'm going to plug in this x plus h everywhere I see an x. So I just have the x as the squared piece, and then if I distribute, I'll have x squared plus 2xh plus h squared, and you can distribute the 10. So this is the first answer. The second one asks you to take what you just got and subtract off f of x. So I'm going to take my previous answer. I'm going to subtract off of f of x. F of x is 10x squared. Notice that this minus 10x squared and this positive 10x squared, they add together to be 0. So this is what I'm left for my answer in the second part. Part C, the numerator is what we found in part B, and we're going to divide by h. So I have 20xh plus 10h squared all over h. I'm going to factor an h out of the top. So if I pull an h out of each of those terms, I'm left with 20x plus 10h. So because it's h times that expression, these two reduce to 1, and you're left with just the 20x plus 10h. And in the last part, you're asked to evaluate the derivative. So the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. I've already got this expression, so this is the limit as h approaches 0 of 20x plus 10h. I don't have any divisions by 0, so all I need to do is plug 0 in for h, and I'm left with 20x. So 20x is the derivative of 10x squared. The second question, I don't remember exactly what they asked, but this is really the graphical interpretation of derivative. Remember that the derivative, or f prime, at every point is the slope of the tangent line at that point. So over on this side, I'm going to try to sketch the derivative. And on the left, I'm going to use the graph to help me analyze it. So first thing I want to do is think about where is the derivative 0, and 0 would mean where it has horizontal tangent lines. So at those three values, so right here, here, and here, I'm going to cross the derivative will cross the x-axis. So I will go through this point, this point, this point. Before this point, so on the left side, my function is decreasing. If f is decreasing, that means that f prime is negative, and negative means below the x-axis. So I'm going to be below the x-axis before that point. In between these 2 points, my function is increasing, and if f is increasing, that means f prime is positive or above the x-axis. So between these two, I have to connect them. I'm going to be above the x-axis. Now, I don't know, it could look like this. Who knows? Just, this is a sketch, so it's above the x-axis and those two are connected. Repeating this for the next part is decreasing, so I'm below the x-axis. And then finally, this last part on this side, I'm increasing, so I'm above the x-axis. So this is my multicolor sketch of the derivative.